It came with about 30% charge, and it comes with mine came with a 400 watt solar panel, and I just connected it up. It's late in the afternoon. I just got home from work and it was ready for me. And as you can see, it's producing about 127 watts of power. I need to position it correctly, but right now I'm just getting it set up. And this will be my backup battery supply. Instead of having a backup generator that uses gasoline, I will just use a battery powered system. I'll connect devices to this battery, and especially my refrigerator. My refrigerator stays powered, and it's inside the house, so I don't have to worry about fumes, and I don't have to worry about interruptions. So this is a really cool device, and I'm hoping it works out good for me. And so right now it's producing about 120 watts of power, and the sun is getting ready to set. It's about I would say at least 5 p.m. right now, and so it's later in the day. As you can see, a lot of shading close by, and it's got about 30% charge, 32% charge. 10 hours of use is available at this point, depending upon the load. So this is the side that has all the USB connectors, both USB A as well as C, and it even has a 100 watt system. All right, I'm going to swing around to the opposite side, and that's where we have our AC connections. As you can see, there are 6 AC outlets here, rated for 20 amps each. Here's my DC input coming from solar panels, so that's providing a charge. I can also charge DC from my car. Now I can use my Tesla through the DC-DC interface, charge this battery up in case we're out of power from my vehicle, or vice versa. I can charge my vehicle from this battery as well. So there's my AC input. I can plug in and it'll charge up this battery. It takes about 2 hours for a full charge to charge it up, or I can just use solar as a way to give it its supply. So lots of options. All right, so this is an EcoFlo Delta Max. Here's the cables that came with it, and it was delivered via FedEx. So thank you, Delta, for actually I bought it from Costco, from their online service, and not bad considering you could supply a lot of essential circuits with this battery backup right here. So it'll cover all your appliances except for your AC. Unless you have a portable AC or a window unit, you could supply power to that. It might give you about 10 hours worth of charge. All right, now I'm doing a high load check. Currently I have the toaster running, and it's consuming about 790 watts, close to 800 watts. And according to this, with just this device being used with 75% on the charge level, it could be about 1 hour's worth of use. Now, I wouldn't obviously use a toaster oven for 1 hour. It'd only be a couple minutes, but give you an idea. And I'm going to pause it here and show you where I'm at towards the end of the cycle. Okay, the toaster just finished, and as you can see, it dropped to 72%, and as you can see, there's no more load on it, so the output watts is only 0. Good morning, everybody. I just wanted to let you know I'm getting ready to test my new EcoFlo Delta Max, and I'm checking individual loads. In this particular case, it's going to be my coffee maker, and I'm starting here at 71% state of charge on the battery. So I'm going to go ahead and hit start for my coffee maker, and we have it plugged into this battery. And let's see how it works. All right, so both amber lights come on, and what's going to happen is that water tank is going to heat up the water. Now note, I'm using a thermal carafe, so there is no heater for this, so it doesn't use a lot of energy after it brews the coffee. So as soon as the coffee is brewed, those two lights on those switches, or two lamps at the bottom I should say, they will still remain on until I turn the power switch off, and they're just LED lamps. So there's my coffee brewing, and this is a Mocha Master. If you haven't looked at one of these, I would highly recommend it. Alright, so we know it's now brewing, and let's go ahead and take a look at the output, and we're looking at 1354 1300 maybe 64 watts. So we've got a lot of power draw right there just to handle the brewing cycle. And that's going to take a few minutes, and it should be pretty consistent. Once it's heating at a certain level, the wattage will be consistent. So I'll come back here just as it's getting close to the end. And keep in mind that once this cycle stops, the amount of electrical draw out of this coffee maker is going to be real small. See you in a few seconds. Okay, and we're getting close to the end of the cycle. As you can see, the water is just about out of the water storage tank. And as you can see now, look what happened. It cut off the power going to that unit because it's not needed anymore, and we dropped down to 64% from 71%. So with this coffee maker here, once the brewing cycle is completed, the power draw is pretty much off except for those lamps at the bottom, and those are LEDs, so the amount of draw is real small. And 7% drop by just brewing coffee. Yesterday we showed an example of a toaster oven. So if I wanted to toast yesterday, it'd only take, I think I lost 3 or 4%. So that wasn't too bad. Remember, no gasoline, no maintenance, just plug and play. And be ready in case of a power outage. All right, next stop, the microwave. Let's see how it does producing a meal. Okay, I'm getting ready to do my microwave test. I got a frozen meal to heat up. It's going to take about 5 minutes on my microwave. And as you can see, I've got 64% state of charge on the battery at this moment. So let's go ahead and do some magic work with the microwave. Now remember, this is assuming that I have a power outage. So I'm going to go ahead and clear that since I had to unplug and put in 5 minutes. All right, so that's 5 minutes. Let's see how this bad boy is handling it. Okay, we're at 81 watts. All right, so it's producing a lot of power. I'm going to move this just slightly to the left because there's the outlet for the air, so I just want to give it some more air circulation. So we're looking at 1785, and we're at 63% state of charge. And what I'll do is I will come back to you once we get towards the end, and we're at 4 minutes and 15 seconds left. So I'm going to pause this and come back, and you can see where we end up after a 5-minute 1100 watt microwave oven, and it's consuming 1760 watts right now. Alright, see you guys in a few minutes. Okay, back with about 13 seconds worth of time left on my meal, and where are we at here, gang? We're at 54%, so we lost about 10% charge. Okay, there it is, the end of that cycle. And looky here, we went to 54, so we lost 10% on a 5-minute microwave heating meal. Cool. What I'm going to do now is to now check this little mini oven fryer. All right, with the next phase of the test, I'm going to use my air fryer oven, toaster oven, since that's what I'll be using in case of a power outage. And right here we can see we're at 52%. I just used 2% doing a test, so it dropped down some. But now I'm going to do is I'm going to turn this on. We've already got it set for bake at about 350, and I'm just going to put it towards 10 minutes. Now let's take a look and see what that draw is. We're looking at 1750 watts. All right, so that's close to the amount of watts that was coming out of my microwave here and my test there. And this is going to run for a few minutes, so we're at 51% already. And I'm going to run this, I've set it for 10, but you know what? It probably will be a little bit less in the interest of, just trying to reheat it. I'm not cooking it. I am just, it was in the refrigerator, and it's just heating up. And that would be, and I figure with about 10 minutes, that's usually how long it takes to cook something in this oven. And this is much more efficient than, let's say, your wall oven or your console. So here we go. I'll come back here towards the end of the cycle and see how it does. Okay, that oven has gotten up to operating temperature, and when it did, it dropped off here, and you can see it's at about 37%. 37 watts, excuse me. And it's just operating a fan. So that's what the 37 watts is, just about a fan. So just a little heads up on the cycles here. Okay, that little air fryer toaster oven just turned off at the end of its cycle. So let's see what we got here as far as load. Okay, we've got 38% state of charge now after performing this test. So this definitely was the heavy consumer, and it's understandable. I'm using about 1800 watts of power for 10 minutes, so it's going to be the biggest draw. So there's an example. I just heated up my breakfast sausage, and we're all good to go. All right, next stop is going to be the refrigerator. Okay, I just turned the system on. We're at 38% state of charge, and got the refrigerator plugged in, and we're looking at about, right now, 595 watts. That's pretty high. I purposely opened the doors as a way to kind of run it through its cycle. And you can see power's on, lights are on. And we're at 590. It'll run through a cycle here in a minute, and we'll keep an eye on it. I'm going to let it run for a while, just to kind of get an overall view as it cycles through its different modes. So I'll probably take a shower, hang out with that, and so 37% is where we're at now, and we're at 586 watts, which seems pretty high. Okay, talk to you later. Okay. We have this system, we have the refrigerator connected to the battery charger, and it's at 23% right now, and I think I have it set to shut off at 20% just to protect the battery. So what I'm going to do is, we've been running it for about just almost an hour, and it's dropped maybe, I think, about maybe 10% or 11% for an hour's use. What I'm going to do now is I'm going to connect it to the solar panels. It's just about 10 a.m. and from 10 to 2, that's the best solar production. And I presume I will get to the 100% level or 80% level. I'll make adjustments to charge it higher. I think I might go to 90%. Anyway, so that's the refrigerator use for about an hour. And we're looking at 23% state of charge. I believe it was 34 when we started the test. Okay, next stop, solar. Okay, now I'm doing my solar charging. Here's my driveway. Got a 400 watt solar panel that came with the kit. It's connected, and on the front face, you can see it's producing about 218 watts right now. It is a 400 watt panel, but we'll probably get to about maximum 350, even though the rating says 400. It's usually a little bit less. That's the optimal percentage. So right now we're at a state of charge of 23%, and we'll let that run for a while. So it's 10 a.m. I just did a bunch of load tests, and I've got it set up to run between 20 and 80% just to protect the battery life. And so we are at 10 a.m. and the sun is just getting closer to its peak time periods. So I'll go ahead and see if I can fine-tune this and get some more higher wattage outputs based upon the position of these panels. Okay, talk to you soon. Now we're at about an hour of charging with the solar. I'm producing about 255 watts, and we moved up to 37% state of charge. So that's after 1 hour, and so it's 11 a.m. now, and we'll see what happens at 12 o'clock. Okay, we're at noon here in Bartlett, Tennessee, and we're looking at about 270 watts of production out of the solar. It raised it to 51% state of charge. We're just after 1 p.m. and we're at the peak solar production right now, and we are at 220 watts, and the capacity is at 67% now state of charge. So we're looking pretty good. Just be aware that I just got a cloud come through, or a light cloud, and before I was at 280 watts, and right now it's at 205, mostly because of a little bit of shading from the clouds. There's a little bit of light clouds up there. Nothing too big, just a little bit. Now I'm at just after 2 o'clock, and as you can see, I'm getting good solar production here. I've got 81% state of charge. 259 watts is currently in use. If you hear some noise in the background, that's my neighbor's generator that uses gasoline. By the way, you might have noticed earlier when I was doing this generator, it had no noise. So just be aware of the side benefits of going to a electric power generator, especially if it's solar assisted. Alright, so I'm at 81%. What I'm going to do now is disconnect and then run it through my car to see how the car charges. Okay folks, I've plugged in on the back end directly to my 12 volt DC connection. This used to be the cigarette lighter connection, and as you can tell, it's no longer used for cigarette lights, but now it can be used to charge my power generator, and we're looking at 112 watts of power coming in. We're at 81% state of charge. Cooling fan just kicked in. And what I'm going to do is, by the way, my vehicle is 9 years old, over 9 years old, so the warranty period is over. And so for people that have a warranty, that might be something to consider. The stipulation is in the Tesla warranty is that should not be used as a stationary power method, a stationary power source method. Now I'm going to treat this just like a cell phone, right? You connect your cell phone to charge up through your cigarette lighter port. You also have other devices like a small battery storage. I'm going to move the vehicle and start driving, and now we see it's all good. All right, and just wanted to show you that it works. Now I have the EcoFlo Delta Max connected to my refrigerator and also plugged into the AC power source. And this would, the intention of this is to provide an uninterruptible power source. So let's say, for example, I'm on vacation or I'm out of town, and power goes out. I don't have to worry about my refrigerator or freezer defrosting or spoiling my food inside. This EcoMax will back it up. And right now, you can probably hear the cooling fan going because it's charging up. It's going to go to 80% and then turn off. And after that, what it should do is just cover in case there's a power outage. Delta EcoFlo Max has just recharged to 80%, which I set as the limit. And you can see there's 126 watts input and 126 watts output. They're the same. So theoretically, if there should be a power drop, that 127 in will not be there, and therefore the battery will then take over. And I could probably simulate that as well. But that just shows you how this system will work and ensure that the refrigerator will have power if we lose power at a time period when I'm not at home. And that could definitely be an issue. All right. Thank you.